Welcome everyone, and thank you for joining us on this webinar held as part of Victoria Building Authority Practitioner Education Series. My name's Erna Lay, Manager of Technical Services, and I will be your host for today. Please note, we are introducing a hybrid webinar that combines live streaming of learning content with interactive poll and Q&As answered by our technical team. So I encourage you all to please type your questions in the Q&A chat functions during the live streaming and also to participate in the live polls. Today's webinar is about introduction to condensation management. So yeah, please enjoy. I'd like to begin by acknowledging the traditional custodian of the land on which we meet today and pay my respects to the elders past and present. I extend that respect to Aboriginal and Torres Strait Islanders people attending the session today. Our presenter today will be Christian Williams. Christian is a Senior Technical Advisor within the Technical and Regulations Building team. Christian has more than 30 years experience in the building industry and 10 years working at the VMIA. Christian has extensive knowledge, experience and qualification in building construction, building surveying and fire safety engineering. As Victoria's building and plumbing regulator, the VMIA is committed to ensuring a confident and thriving industry and collaborates with stakeholders to enhance practitioner competencies and deliver improved outcomes for the community. We have a role in ensuring practitioners understand how to do things correctly and in discouraging risky, harmful or illegal behaviours in the building and plumbing industries. Today's webinar will be about an introduction to condensation management, focusing on the changes as part of the NCC 2022. Now, before we begin, I'd like to let you know that this session is being recorded and the link of this presentation will be made available on our VMIA website along with our previous webinars. We will be answering some pre-submitted questions during the Q&A session at the end of the hybrid webinar. Please still submit your questions via the Q&A chat function during the presentation, as our technical team is still available live to answer your questions in the chat room. Also during the webinar, we will be conducting a live polls that will automatically appear on your screens, so please feel free to participate on them. And also please use the QR code reference on the slide to direct you to the relevant website relating to the topic being presented today. Just a brief reminder, due to the large volume of questions we received during the live streaming of the learning content, we will do our best to answer as many of these questions as possible. After the hybrid webinar, we will collate all the unanswered questions and will provide answers to as many of these as possible. Again, a copy of the Q&A will be sent out in the weeks following this hybrid webinar. Christian, I will now hand over to you.
Thank you, Erna, and welcome all to the webinar. The purpose of this webinar is to outline condensation management for NCC 2022 in order to prepare the industry for the upcoming changes that will be adopted in Victoria on the 1st of May 2024. From attending this webinar, you should have a better understanding of what the new requirements for condensation management are for NCC 2022, as opposed to what is required under the 2019 version, which is still currently in use until the 1st of May 2024, and also gain an understanding of the pathways to achieve compliance with the condensation management provisions of NCC 2022. So today in this webinar, we'll discuss the following topics. We'll briefly discuss condensation and condensation management, what the purpose of condensation management provisions of the NCC are. Then we'll get into NCC 2022 requirements, starting off with a comparison to Volume 1 and Volume 2, and then the details of the performance requirements, the verification methods, and deemed to satisfy provisions. Before we take you through the condensation management requirements, we need to mention one of the main changes to the NCC, which is the new SPTC referencing system. To help improve the readability of both volumes, the Australian Building Codes Board, or the ABCB, have come up with what they call SPTC, which stands for section, part, type, and clause, which can be seen on the left side of the slide. Anyone who's familiar with Volume 2 should know that Section 2 used to contain the performance requirements, and those two sections have now been combined into one section called Section H. Essentially, the aim for this change is to make all volumes in the NCC consistent. To quote an example on the right side of the slide, we know Volume 2 is designated Section H, which is for Class 1 and 10 buildings. Sections are then divided into parts. A section can have multiple parts dealing with different aspects relating to that section. In our example, it's Part H4 to do with health and amenity. The type can be one of 7 options, as shown on the left side of the slide. This can be the governing requirements, performance requirements, objectives, functional statements, verification methods, deemed to satisfy provisions or specifications. In our example, the type is D, which stands for deemed to satisfy provision. The clause is always a number. In our example, the number is 9. So when I go to that reference H4D9 in Volume 2, it'll give me the deemed to satisfy provision for condensation management. For the first part of this webinar, we're going to briefly discuss condensation and its management. Condensation is an event which reveals the presence of water vapour in the atmosphere, and in this particular case, in the context of buildings. The NCC defines condensation as the formation of moisture on the surface of a building element or material as a result of moist air coming in contact with the surface at lower temperature. When the resulting water vapour from condensation is unable to dry as readily as it forms, it can accumulate to cause problematic wetting in buildings, which can result in the growth of mould or the deterioration of building elements. In dwellings in particular, the daily activities that occur, such as cooking, washing, showering, bathing, and laundry, release water vapour. Furthermore, people release more water vapour into the air just by breathing and transpiration from the skin. All this water vapour accumulates in buildings and needs to be released to assist in reducing the likelihood of excessive condensation. This is because mould growth can be stimulated at relative humidities above 70%. With the increase of building sealing in recent times, it has become necessary for the NCC to include requirements to mitigate against the accumulation of excessive condensation. The Australian Building Codes Board, or ABCB, commenced a project starting with the new condensation management provisions for NCC 2019 in an attempt to reduce the presence of condensation and mitigate its effect on buildings. This is a continuing project which is progressively implementing new condensation management requirements to the NCC as more research and information becomes available. The condensation management provisions of the NCC aim to decrease the risks of condensation and water vapour to the health and amenity of occupants of residential buildings only. The condensation management requirements apply to Class 1 buildings, Class 2 sole occupancy units or SOUs, and Class 4 parts of buildings, and are contained in both Volumes 1 and Volumes 2 of the NCC. It is important to note that the installation of a condensation management system may not necessarily prevent condensation from occurring and are mostly in place to mitigate its effects. Before we get into discussing the changes for NCC 2022, it's important to point out that most of the changes with respect to condensation management are identical between volumes 1 and volumes 2, but with some slight variation. As most of the changes for volume 1 and volume 2 are identical, we will not be going over the changes twice, and we will be covering most of the requirements from a volume 1 perspective, but also outlining where these changes occur in volume 2. So for those of you who are only interested in the requirements for volume 2, take note, as most are the same. However, we'll now provide a brief comparison between volumes, showing where these differences occur. The table on the slide compares the building classes, performance requirements, and verification methods of volume 1 and volume 2. You can see in the third column and highlighted in green that the performance requirements and verification methods are identical for both volumes for NCC 2022. This table compares the DTS provisions for NCC 2022 in volumes 1 and volume 2 under the ABCB Housing Provisions Standard 2022. You can see in the first row that the requirements for external walls that relate to pliable building membranes, in that the requirements for both volumes are again identical, highlighted in green in the third column. The second row on the table compares the DTS requirements for exhaust systems for NCC 2022. You will note, as highlighted in yellow in the third column, there are some slight differences between volume 1 and volume 2 with respect to the requirements for exhaust systems. The first difference is that under volume 1, where a space for a clothes-drying appliance is provided, a space must also be provided for ducting the appliance to outside air. However, for volume 2, you are only required to duct a venting clothes dryer where a venting clothes dryer is to be installed. So basically volume 2 is reliant on a venting dryer being installed, whereas volume 1 requires a space for the ducting where a space for a dryer is provided. The second difference is that under volume 1, required exhaust systems must be provided with make-up air in accordance with Australian Standard AS 1668.2, 2012, the use of ventilation in buildings. Whereas under volume 2, there is an option for make-up air to be provided by having 14,000 millimetres square, of free open area to an adjacent room in lieu of complying with AS 1668.2, except for where a venting dryer is installed, which must be ducted to outside air. The last row on the table compares the requirements for the ventilation of roof spaces. You can see once again, as highlighted in green in the third column of the table, that the requirements for the ventilation of roof spaces are identical again for volumes 1 and volumes 2 for NCC 2022. We will now discuss the changes for NCC 2022 with respect to condensation management to be adopted on the 1st of May 2024, beginning with the mandatory requirements of the NCC, which are the performance requirements, and then onto the verification methods, which is one of the assessment methods under the mandatory provisions of the governing requirements under Section A of the NCC. Under Volume 1 of the NCC, the performance requirements for 2022 have not changed much. Condensation management has been moved from Part F6 in the 2019 version to Part F8 for the 2022 version. The new performance requirement is F8P1 under the new SPTC numbering system, as we discussed earlier. There is again only one performance requirement in Volume 1 for 2022, which has been rewritten slightly for clarity, with a separate application box noting that it only applies to a sole occupancy unit or SOU in a Class 2 building or a Class 4 part of a building. As discussed earlier in the...
Sorry, Nandini, I'm just going to interrupt here. Apologies, everyone. Do you want to try streaming it again, Nandini? Please. Just bear with us, guys.
Condensation management has been moved from Part F6 in the 2019 version to Part F8 for the 2022 version.
Can you just pause it, Nandini? The
The
slide's
new
really
performance
blurry.
requirement
Just play it again.
is F8P1 under the new SPTC numbering system, as we discussed earlier. There is again only one performance requirement in Volume 1 for 2022, which has been rewritten slightly for clarity, with a separate application box noting that it only applies to a sole occupancy unit or SOU in a Class 2 building or a Class 4 part of a building. As discussed earlier in the webinar, the performance requirements for Volume 2 used to be contained under Part 2. However, for the 2019 version of the NCC, the whole of Volume 2 is now called Section H. The condensation management provisions come under Part H4. And again, there is only one performance requirement under Volume 2, which is H4P1, applicable to Class 1 buildings only. There are no changes to this performance requirement for NCC 2022 other than the SPTC reference. For NCC 2022, there's a new verification method under Volume 1, which is F8V1, which now introduces a quantifiable method of complying with the performance requirements. There is also a verification method, H4V5, under Volume 2, but as it is identical to the verification method under Volume 1, we'll not be discussing H4V5 in this webinar. It's important to note that verification methods are not a mandatory component of the NCC. However, they do form part of the mandatory assessment methods under Clause A2G22 of the NCC, which can be used to demonstrate compliance with the performance requirements. The main changes to the verification methods for NCC 2022 are references to a guide produced by the Australian Institute for Refrigeration, Air Conditioning and Heating, or IRA. The guide is IRA DA07, Criteria for Moisture Control, Design and Design Analysis in Buildings, which was put out in 2021. You can access this document for a cost through the QR code link to the IRA website on your screen. We would suggest this document typically only be used by design professionals who intend on using the verification method or are wanting to use the document to formulate their own performance solution, or maybe by building surveyors who are assessing performance solutions if they wish to verify the information presented in that report. The DA07 guide provides performance-based design criteria for predicting, mitigating, or reducing moisture damage to the building envelope, the materials, components, systems, and furnishings based on a number of factors. It can be used with software packages that are able to carry out hygrothermal analysis. Hygrothermal analysis meaning the movement of heat and moisture in a building. The verification method requires that a roof or external wall has a mould index less than or equal to 3 on either the interior surface of the water control layer or on the surface of the components interior to the water control layer. The mould index must be calculated using the input assumptions and intermediate method for calculating indoor design humidity from section 4.3.2 of the IRA DA07 document. A mould index equal to 3 is described as findings of mould on the surface of a material visually with less than 10% coverage or 50% coverage of mould when viewed by microscope. Mould index values less than 3 correspond with the mould growth only visible by microscope. It's now time for a quiz to recap our learning. The poll questions will come up on your screen automatically for you to answer. The first question is, what does the SPTC in the NCC referencing system stand for? A, section, part, type, clause. B, system, part, type, clause. Or C, system, paragraph, title, clause. The second question is, there are no changes to the performance requirements for condensation management under Volume 2 for NCC 2022. True or false? Let's see how you go with the answers. So question 1, what does the SPTC referencing system stand for? The answer was A, section, part, type, or clause. Question 2, there are no changes to the performance requirements for condensation management for NCC 2022. Answer was A, true. We now come to the main part of this webinar, which will discuss the changes to the deemed to satisfy or DTS provisions of the NCC with respect to condensation management. As discussed earlier, as the provisions for condensation management under Volume 1 and Volume 2 are almost the same, we will not be discussing the DTS provisions of Volume 2 in any great detail, and will instead only be identifying the changes under Volume 2, which are different to Volume 1. There are some significant changes to the DTS provisions for condensation management for both Volume 1 and Volume 2 of the NCC for 2022. These provisions will apply to a Class 2 buildings and a Class 4 part of a building under Volume 1 and Class 1 buildings under Volume 2. Again, they will only be adopted in Victoria on the 1st of May 2024 for condensation management. And as we did with the previous section, where the DTS provisions for Volume 1 and Volume 2 are identical, we will not be discussing them again when we get into the Volume 2 provisions. So we'll now start off by discussing the new requirements under the deemed to satisfy provisions of Volume 1 for NCC 2022 with respect to condensation management. To start us off, there's a change to the provisions for external walls under Clause F8D3, which relates to pliable building membranes. These are also commonly known as cisolation, reflective foil insulation, or wall sarking. However, pliable building membranes are defined in the NCC as being a water barrier, which is classified under Australian Standard AS 4200.1 2012, pliable building membranes and underlays, materials. For 2022, pliable building membranes are now also required to be vapour permeable in climate zones 4 and 5, in addition to climate zones 6, 7 and 8, which was originally required under the 2019 version of the NCC. So what does this mean for Victoria? We can see in the map on the screen that most of Victoria is in climate zones 6 and 7, as shown in the light and dark blue shading. And climate zone 8 is shown in the white areas. However, there are still some areas at the top of Victoria, such as Shepparton and Echuca, that are in climate zone 4, as shown in yellow at the top of the map. This basically means that a pliable building membrane is required to be vapour permeable throughout all areas of Victoria. The requirements for climate zone 4, shown in the yellow shading, can be met by installing a Class 3 or 4 vapour control membrane as defined under AS 4200.1 and installing it in accordance with AS 4200.2 2012. A Class 4 vapour control membrane will satisfy the requirements for climate zones 6, 7 and 8 as shown in blue and white actually. The figure on your screen shows a typical installation of a pliable building membrane, which is shown in red, with a direct fix cladding system, which is considered to be the primary water control layer. This example shows a Class 3 vapour control membrane, which would satisfy the requirement for a climate zone 4, which is around the top of Victoria as shown in the previous map. Drawing your attention to the second figure on the slide, as a vapour permeable pliable building membrane is required throughout Victoria, where a pliable building membrane is not installed, the primary water control layer, or the masonry in this example, must be separated from the water sensitive materials, such as the timber frame, by a drained cavity. The intent of this clause is to ensure that when no wrap or sarking material is used, a drained cavity is installed between the primary water control layer and any water sensitive materials. This clause is not intended to allow substitutions where untested vapour permeable materials are installed instead of a pliable building membrane. This means that untested vapor permeable materials should not be used, as there is a potential for condensate to accumulate and damage the water sensitive materials. There are a number of important changes to note for exhaust systems under F8D4 for NCC 2022. While the flow rates for exhausts remain the same, there are new discharge requirements that apply. Exhausts from bathrooms, sanitary compartments, and laundries can no longer discharge into a ventilated roof space, and all these exhausts, including kitchen range hoods, must now be discharged directly outside air via a shaft or duct. It's important to note that the installation of exhaust ducts to outdoor air must be carried out by a licensed plumber. Under clause F8D4, where a space for a clothes drying appliance is provided to satisfy the requirements for laundry facilities under Part F4, a space must also be provided for ducting the appliance to outdoor air, and make-up air for the exhaust must be provided in accordance with Australian Standard AS 1668.2 2012, the use of ventilation and air conditioning in buildings, mechanical ventilation in buildings. The exception to providing an exhaust system and make-up air is where the room has natural ventilation in accordance with clause F6D7, or where a condensing type dryer is to be installed, as they capture the water vapour and the clothes dry and condense it into a liquid water that can be disposed of. The final important change for exhausts under F8D4 is where an exhaust system is used to ventilate a bathroom or sanitary compartment in lieu of natural ventilation, and that exhaust does not run continuously. In this case, the exhaust must be interlocked with the light switch and operate with a run-on timer so that the exhaust will run continuously for at least 10 minutes after the light switch has been turned off. The last change under Volume 1 is in relation to the ventilation of roof spaces. Currently, under the 2019 version of the NCC, roof spaces are only required to be ventilated where an exhaust system is discharged into the roof space. However, for NCC 2022, the ventilation of the roof space is a mandatory requirement for climate zone 6, 7 and 8, which is most of Victoria and is shown in blue and white shaded areas on the climate zone map on the screen. Clause F8D4 requires that the roof space must be above the primary insulation layer, which under the definition in the NCC, primary insulation layer is the most interior insulation layer of the roof, or the NCC requires that the roof space must be above sarking, which is immediately above the primary insulation layer, or the roof space must be above ceiling insulation that complies with the energy efficiency requirements under Part J3 of Volume 1. The roof space must also not be less than 20 millimetres in height, and the roof space must be ventilated through evenly distributed openings. Alternatively, the roof space may be directly beneath a tiled roof if no sarking is installed, in which case no additional ventilation will be required. The requirement to have a ventilated roof space is also not applicable to a concrete roof. Insulated structural roof panels, such as reinforced EPS concrete, or roofs required to be built to bushfire attack level FZ requirements. Where the roof space is required to have evenly distributed openings, the requirement specifying the amount of ventilation and its placement is based on the roof pitch, as you can see in the extract from table F8D5 on the left of the slide. The figure on the right of the slide is an extract from the NCC, showing that the 20mm gap for the minimum required roof space must be maintained between the ceiling insulation and the roof sarking, and shows a typical eaves vent. We're now going to go through a very basic example of calculating the roof space ventilation requirements using table F8D5 for a roof pitch between 15 and 75 degrees. We'll be using two vent types in this example, as can be seen in the middle box at the bottom of the slide, which are eaves vents and ridge vents for high level vents. These are required to be within 900mm of the top of the roof or the ridge. Please note that the free opening area of the vents will be less than the size of the actual vent itself, as the majority of vents are slotted and only the free area of the vent slots can be used for determining the required ventilation. The roof you can see on the slide shows a 16-metre long gable end roof with a 31-degree roof pitch. On the bottom left of the slide, you can see the calculation for eaves vents. For a pitch between 15 and 75 degrees, table F8D5 requires 7,000 millimeters squared minimum free opening area per linear metre at the eaves, based on the longest horizontal distance of the roof or the longest side of the roof, as you can see in the figure. We therefore need to multiply the required opening area of 7,000 millimeters squared by 16 meters. This gives us our total required opening area for the eaves of 112,000 millimeters squared. As the example roof has two eaves, we need to divide the total opening area by 2, which gives us 56,000 millimeters squared at each eave. If we had 4 eaves, we would have to divide our total by 4. Now that we have our required opening area for the eaves, we now need to determine the required number of vents based on the size we have adopted. For our example, the eaves vents have a free opening area of 10,000 millimeters squared. This means we now divide our total opening area for each eave by the free open area of the vents to determine the number of vents required, which is 56,000 millimeters squared divided by 10,000 millimeters squared, which gives us 5.6. As we cannot physically divide one of our vents up to 0.6 of a vent because it may no longer be functional, we'll need 6 vents per eave to meet our eave ventilation requirement. Please note that all vents must be evenly distributed. The same method will need to be used to calculate the high level ventilation required under table F8D5 as shown on the bottom right of the slide. Except in this case, we are using ridge vents, which have a free open area of 20,000 millimetres squared. With the high level vents, they need to be placed within 900 millimetres vertically of the top of the roof or ridge, and we again need to multiply the required area of 5,000 millimetres squared by the longest horizontal dimension of 16 metres, which gives us a total opening area of 80,000 millimetres squared. As our ridge vents have a free opening area of 20,000 millimetres squared, we once again divide our total required opening area of 80,000 millimetres squared by the vents free area of 20,000 millimetres squared. This will give us 4. Therefore, in this example, 4 high-level vents will be required to meet our high-level ventilation requirement. Once again, these four vents must be evenly distributed. We'll now have a quick quiz once again to test all your knowledge. For question 1, under clause F8D4, exhaust systems, how long must the continuous timer run after the light switch is turned off in a bathroom or sanitary compartment in lieu of having natural ventilation? First choice is A, 5 minutes. Second is B, 10 minutes. Third is C, 20 minutes. Question 2. Under NCC 2022, Victorian climate zones will affect when the ventilation of roof spaces and pliable building membranes are required. A, true, or B, false? Let's see how you go with these ones. So for question 1, under F8D4 exhaust systems, how long must the non-continuous timer run after the light switch is turned off in a bathroom or sanitary compartment in lieu of natural ventilation? Answer was B, 10 minutes. For question 2, under NCC 2022, Victorian climate zones will affect when the ventilation of roof spaces and pliable building membranes are required. Answer was A, true. We'll now come to the changes to the DTS provisions for Volume 2 of the NCC under Section H, which are specifically contained within the Housing Provisions Standard 2022. We'll cover the changes. However, again, as the majority of the requirements are identical to Volume 1, we'll only be detailing any provisions that are different in Volume 2. Firstly, the DTS provisions for Volume 2 have a different structure for NCC 2022, as noted earlier in the webinar. The DTS provisions for condensation management are now under clause H4D9 of Volume 2, which references Part 10.8 of the Housing Provisions Standard 2022 to achieve compliance. Clause 10.8.1 of the ABCB Housing Provisions Standard sets out the requirements for external walls and is identical to the requirements under Volume 1, as we discussed earlier. However, Clause 10.8.2 that relates to exhaust systems is almost identical, but with some slight variations. 10.8.2 subclause 3 requires that where a venting clothes dryer is installed, that it is ducted to outdoor air. This is different to volume 1 as it is dependent on the dryer actually being installed, whereas under volume 1 it is a requirement, even where only a space is required for a clothes drying appliance. The 10-minute run-on timer for bathroom and sanitary compartments that we spoke about under volume 1 is also required under clause 10.8.2 subclause 4 of the Housing Provision Standard. Under clause 10.8.2 subclause 5, it requires make-up air in accordance with 1668.2, the same as volume 1. However, the difference with this clause is that it also permits an opening to an adjacent room with a minimum dimension of 14,000 millimetres squared in lieu of complying with AS 1668.2. However, all other exhaust requirements are identical. And to finish off the condensation management provisions under clause 10.8.3, the provisions for the ventilation of roof spaces are again identical to volume 1 as presented earlier in our webinar. So in today's webinar, we've outlined the new requirements for condensation management for NCC 2022, and we hope that this will assist the industry to prepare for the upcoming changes that will be adopted in Victoria from the 1st of May 2024.
I just wanted to say thank you all for joining us today, and I hope that you have learned something and have enjoyed the session. Just a reminder, we will collate all your unanswered questions in the chat functions, and we'll answer them, provide an answer to these, as many as possible in the coming weeks. We will be sending out an email that includes a webinar survey, as well as your proof of attendance and links to today's webinar and slideshow. To find out when our next practitioner education series webinar will be held, please head to our websites and keep an eye out on your emails as well. Thank you again for taking the time to attend, and have a wonderful day.
Thank you.
Thanks, Christian.